Now we're looking at semicircles. Now when you see an equation of the form y equals, it'll either be positive, so you won't see the plus. So if you see y equals the square root of r squared minus x squared, or you see y equals the negative square root of r squared minus x squared, those are the equations of a semicircle. Now we're going to look at 4 types of semicircles. Semicircles above the x-axis, below the x-axis, and then we're going to see sideways ones as well. So to know, see, sometimes people get confused. They're not sure if it's the equation of a semicircle or not. So what we do, so this is the equation of a semicircle with center 0, 0, radius r. Let's see how we derive that equation. You know how we know? We'll start from somewhere that we know. We know that the equation of a circle is x squared plus y squared is r squared. I'm going to make y the subject, so I'm going to take x squared over, right? Rearranging to make y the subject, well, y squared the subject. And then I'm going to take the square root of both sides. So remember, when you're taking the square root, you do plus or minus the square root. Why? Because, for example, if I've got that y squared is 4, for example, this is why we take plus or minus square root, then couldn't y be positive 2 or negative 2? Because negative 2 squared is 4, positive 2 squared is 4, so we go plus or minus the square root. So that's why we go y is plus or minus the square root. Now, which one is which? Y equals the positive square root of r squared minus x squared will be a semicircle above the x-axis. It'll look like that. As all the y values are positive. Why are all the y values positive? Well, when I do the square root of r squared minus x squared, you can only do the square root of a positive number. So that's positive, and there's a positive in front. So you won't see that positive in front. And if I do y is, so I'm going to break this up. There are 2 equations here. If y is the negative square root of that, square root of r squared minus x squared is positive, and you put a negative in front, I'm going to get negative values for the y. So my parabola will be below the x-axis and will look like that. So there's the top part of my circle and the bottom part of my circle. The negative one's always the bottom part of the circle. Now, for example, let's look at the orange graph there. Here. You would recognize that as a circle, well, it's a semicircle, with center 0, 0, radius 6. So I've got the orange graph is a semicircle. This is based on the equation of a circle, x squared plus y squared is 6 squared, or x squared plus y squared is 36. Let's make y or y squared the subject by taking x squared over. We've got y squared is 36 minus x squared. Are we okay with this? And then we'll take the square root, because it's always the function or graph will be y equals. Sometimes it's x equals if it's sideways. We've got taking the square root. I'm going to do, I know it's meant to be plus or minus, but this will be the positive square root, because look, when x is 2, y is 5 point something. When x is 3, y is 5 point something. You know, I can see for all my values of x, y is positive. Can you see that? Up here on the graph are positive y values. So that graph, the orange graph, is y equals the positive square root of 36 minus x squared. All right, let's look at the purple graph. What do you think that equation is? What's the radius? Yeah, it's based on that. So it's going to be y. You can start with that if you want. X squared plus y squared is 4. Y squared is 4 minus x squared if you can't remember the formula. Just 1 minute. One is based on x squared plus y squared is r squared, which is 2 squared, which is 4. So y squared is 4 minus x squared. Sorry, you can't see. And now it's a semicircle. Is it going to be the positive square root or not? Yeah, because it's above. Okay. Now let's look at the blue graph. And are we good? So if you can't remember, all right, but how are you going to know to make it y squared at the front? It's because the graph is sort of about the y-axis. Do you know what I mean? You know how a parabola goes like that? It's sort of about the y-axis, because when we do circles the other way, it's going to be x equals, not y equals. All right? Now, the blue graph is obviously below the x-axis. The blue graph starts from x squared plus y squared is 4 squared, which is x squared plus y squared is 16. Making y squared the subject, and then we take the square root. This is below the x-axis, So it's going to be the negative square root of 16 minus x squared. So look, the main thing I'm worried about here is that people are going to put 4 here instead of 16 because it's r squared. Okay? And the green graph is based on the parabola x squared plus y squared is 1, isn't it? So it's y squared is 1 minus x squared. So it's the negative 1 as well. So it's going to be the negative square root of 1 minus x squared. Are we okay? Now, have you sketched the red and the black? Good. This is of the format y equals the square root of 3 squared minus x squared. Obviously, the radius is going to be 3, the center 0, 0. Sorry, and it's negative. It's below the x-axis. So radius 3, I'm going to come across 3, down 3 there, and try and draw a nice circle. Okay? I know it's not that great. Okay. And so it's got to be a bit more rounded, girls. Make sure it's rounded, especially down there. And the last one has got radius what? Guys? Radius 5. Very good. So that one is of the format 5 squared minus x squared. It's above the x-axis. So radius 5. So go up 5, across 5, there. I'm just going to put a few other points in. Okay. Sorry. Okay, all good? We're going to turn over. These semicircles have x equals. Now, so far in all of the topics so far, we see y equals this, y equals that. You know, y is x squared, y is x cubed, y is 2 to the x, y is 1 on x. And we always see that they're sort of associated, you know, especially with x squared, it's around the y-axis. It'll go like this, or it'll go like that for y equals x squared. These other graphs, when x is the subject, they're sort of turned sideways. Well, they are. They're turned sideways. All right? The y is where the x normally is, and the x is where the y normally is. So you may as well almost think of your page being turned sideways. And then it looks like what we were just seeing. Do you see? See, that's the x-axis. I've just turned my page sideways, by the way. So when you've got x equals at the front, another way, a way that it's sort of easy to think of is that the x is where the y is and the y is where the x is. If you turn the page sideways, it looks like what we just saw with y equals square root. Okay? All right, so let's just keep going here. So we've got, this is a semicircle sitting on the left or the right. So it's sitting on the left or the right of the y-axis, not up and down. Again, we start with the equation x squared plus y squared is r squared. We're going to take the y squared over this time because we know we're talking about sideways parabolas, not parabolas, but sideways semicircles. And then we take plus or minus the square root. So we do have two equations here. The positive side has to give me positive values of x. Do you get that? That's how you know which side it's on. And x equals negative square root, well, all the x values there will be negative. So let's look at the orange graph down here. This is obviously based on a circle with center 0, 0, radius 1. So we start with that. But because it's sideways, we make x squared the subject here. X squared is 1 minus y squared. And then we take the square root, and it will be the positive square root because look at all the x values over here. They're all positive. Okay, so our orange graph is x equals 1 minus y squared. Sorry, I haven't written that very well. Now, what's the purple graph, girls? Based on the circle, x squared plus y squared is 5 squared, which is 25. I'm going to make x the subject because it's a sideways graph, 25 minus y squared. So what's x going to be? The square root of 25 minus y squared. Then we look at the green graph. Again, circle or semicircle based on the circle with center 0, 0, radius 2. We make x squared the subject. Take the y squared over. This will be the negative square root because look at all the x values. X is negative 1, y is positive, whatever. Or x is negative 1, y is negative. X is negative 2, y is 0. See how x is negative? The only way x is going to be negative is if you put a negative in front of that square root sign, because what's under the square root? The square root bit's positive, and you're going to have a positive sorry, we need a negative x value here. This makes sense. All the x values in the green graph are negative. X is negative, and I know that bit's positive. All right? So the green graph is what? X is the negative square root of what? 4 minus y squared, because it was based on the circle. X squared plus y squared is 4. And the blue graph is based on the circle x squared plus y squared is 6 squared, which is 36. We make x the subject. So what is it going to be? X is the negative square root of what? 36 minus y squared. You then were asked to sketch two other graphs. X values here have to be negative. This is the same as negative square root of 4 squared minus y squared. The radius is 4, not 16. It's on the negative side as well. So that one's like that. And the other graph has got radius what? That's the same as 3 squared minus y squared. It's got radius 3. And it's on the positive side. Thank you. Okay, I'll just work down here. Let's say I didn't give you this. It was in an exam, mixed up. You don't know where this equation has come from, right? So let's say I just give you, and I ask you to sketch this. X is the square root of, I don't know, 49 minus y squared, and it wasn't in the context of today's lesson. The other thing you can say, you know how I've said, oh, this comes from a semicircle, etc. What you can do, if you're not sure about what this is, you can just square both sides to say, where did this come from? So if I give you an equation like that, x is the square root of 49 minus y squared, and you do not recognize it as a semicircle. If I square both sides, what do you get? X squared is, I just get rid of the square root, 49 minus y squared, and then I take the y squared over, and I say x squared plus y squared is 49, and now I can say, that's right, that's a semicircle, because it's originated from x squared plus y squared is 49. So that is a semicircle with center 0, 0, radius 7, above or below, and it's x equals, so it's a sideways one, and my x values have to be positive. It's this way. Okay? So if you're not sure, square both sides. The reason is when we do parabolas, they look almost the same. The only thing is it won't be y squared, it'll just be y. And you're going to get confused. You may get confused. So what you do is you square both sides and you say, that's right, that's come from a circle. So that one's a semicircle. And then you say to yourself, normally I see y equals with all my graphs. Y equals this, y is x squared, y is x cubed, y is everything. But this one is x equals. Oh, that's right, that's the sideways type when x equals. All right? So turning over here, for example, if I showed you this, y equals negative square root of, I don't know, 64 minus x squared. If you saw that, you say, you know that it's negative, but when I square it, it's going to be positive. And if you think, where did that come from? You square both sides, you get y squared is. Now the negative, when you square it, becomes positive. And the square root, when you square it, you lose it. It's 64 minus x squared. So I get x squared plus y squared is 64. And you say, that's right, that is, I know my battery's going. You say that has come from a circle. That's a semicircle. It's the y equals type. So it's either, it's the normal type, not the sideways type. And the negative here tells me it's below the x-axis. All right?